Thanks for introduction. Yes, mine was a little, changed after the post session also. So thanks everyone for coming. Today I'm going to talk about work on incorporating word knowledge to document clustering while heterogeneous infinite network. And let's first revisit what is text categorization. So actually, text categorization has a lot of applications, and it's a basic task to mining, like categorize the text category from the massive data. So, for example, it has an application in social network analysis and machine learning. And the traditional approach asks people to provide label data and train, classify, and then make a prediction. So the key problem here is where can we get this kinds of label data? So, the problem in a big data era is, the data we get is more and more actually, from the formal clean data to like the informal noisy data, like short text, okay, like tweets, like web queries, and also we get the label according to this kind of data. From the nowadays we have cost graded data labels such as insurance, and to nowadays we have fine-grained labels such as all kinds of insurance related to the original one. And machine learning always require domain-dependent data with according label to do better like machine learning. So we get more data, we get fine-grained labels. So it gives us a chance to improve all kinds of machine learning ability to create opportunity for more companies, for more applications. Okay, so problem here is how can we acquire this kind of label data? Because all kinds of machine learning needs domain-dependent label to help them to improve their performance. So the first way is we can always ask expert to help us know the data, but this is a very costly process. Only very big companies can help experts to help us to do so, and also crowdsourcing can be a way. But it's oriented to simple text, and it's the results is often suffer from low quality or still costful. And several other machine learning algorithm framework has been proposed, like semi-supervised or transfer learning to this part. But this kind of algorithm are not generous to faster changing domains. Like every day we have new tweets, we have new topics. It's not possible to ask people to annotate data every day or to just do transfer learning. And other things like many diverse domains, come out. They are very rare domains or very, needs a lot of experts, so such as psychology. There's just a little people can help us to know the data. So we are considering a knowledge-enabled learning framework, which we propose to use the knowledge as indirect supervision. So what we do here is that we have a word knowledge, in the form of Freebase, Wikipedia, Yangqiu, this kind of word knowledge. And we can consider whether we can use them as indirect labels, right, to supervise all kinds of machine learning algorithm. We can make it very general, not just limited to specific domains. We can just use it to more applications to more general or more diverse domains. So let's take the knowledge-enabled text clustering as an example. So what we do is that I just give you two documents. It's hard for you to decide which is two documents belong to. But actually it's hard for the machine to do so because if we look at the background words features, there's actually no like overlap background words features between them. So actually, the feature-based clustering algorithm is hard to decide these two whether they belong to the same cluster or not. But actually, we can get a lot of extra knowledge from the word. Actually, we can know that Obama is a politician, and we can also know that Bush is a politician. So we can probably use this kind of link information and anti-type information to help us to improve the clustering algorithm. Okay. So, but the traditional algorithm actually do not use them. So I just give you a real example of our algorithm on the 20 news group documents. You could see that our algorithm actually do not use any, like acquired label data. Just outperforms one of the state-of-the-art clustering algorithms, which is based on co-clustering, theoretical clustering, which uses actually 215,000 like ground truth labels. We can actually outperform them because they just use the ground truth. I tell them whether this document belongs to politics or not. Okay, so this result is somehow interesting and surprising. So what do we face behind this good results? So we have word knowledge, we have data. So the first thing is that the word knowledge is a general purpose knowledge. It's not designed for any domain-dependent task like 20 news group. No. So, but the data is actually domain-dependent. It's a domain-specific data, and also the difference between knowledge and data presentation is another problem. And we should also notice that in knowledge base actually is always the largest scale. So we should consider problem large scale, but actually in the small data, or data is relative, requires small scale reference. So I think it's a general and effective machine learning framework to use knowledge, because we can benefit lots of different applications, such as in this paper we study clustering, but also can apply to classification recommendation, other like machine learning tasks. We can always use the general word knowledge specific to any domain if you use it, the data. So actually we can just use traditional machine learning algorithm with general purpose word knowledge to just generate or just produce a more powerful machine learning algorithm. Now we have big data. Actually, lots of people working on mining insightful knowledge from the data. So if we could get more like word knowledge accurately or improve coverage of the word knowledge, we can get a better performance. So let me introduce what we do with text clustering algorithm with the word knowledge. So first, given the word knowledge base and the documents, so we first do word knowledge specification to specify the word knowledge to the domain-dependent knowledge, and to make the knowledge accurate and useful for the domain task. And then we present such knowledge in a correct form to try to make sure that this kind of knowledge can be used in the downstream task, like modeling, clustering modeling. And then we can just generate estimated label of the document. And let me first introduce specification framework. First, we use semantic parsing. So what is semantic parsing? Semantic parsing is just you input a textual document. It can help you to generate a logic form to represent the meaning of the document. This is motivated by the brands because they just propose a large-scale semantic parsing using the word knowledge to help them to train a semantic parsing using the QA question answering pair. But actually, this kind of question answering we do not have this kind of pairs for the document side. So what we do here is we design unsupervised semantic parsing for document. So what we do is that we first build a lexical between all the phrases and entities in the knowledge base. Okay, we use the unary to present the entity and use a relation to present the binary, and we design lots of grammars or composition rules to combine or to join the binary and the unary and the intersection between the unary and the unary. After doing this recursively, we can generate the final logic form for this sentence. So actually, notice here we want to speed up the whole unsupervised semantic parsing process. So we use a maximum spending phrase to help us to speed up the whole process by only we just pass the United States of America instead of America United States. Okay, so here is an example about our semantic parsing results. So, for example, one document is talking about John Smith came over to Braves from Tigers, but was developed by Braves. Actually, we can know that John Smith can be a baseball player, can be a TV actor, or can be a award winner. But actually, we know that in this document, this specified to the baseball player. So we should find a way to fill out the noisy type of the meaning of the entity out and just preserve the right one. Actually, we try to use a context information in the document to help us to do so. So what do we do? If we know two documents is talking about, the one document include like Apple and Adobe, but Apple can only be, can be fruits or can be branding in the knowledge base, but Adobe can only be brand or software company. So we probably can use relevant related entities, as a cluster to help us to disambiguate the entity with the problem. So we can just use the largest probability of the entity type, using the based on our condition on the related entities. So what we can get is we can find that actually in this document site, John's smooth means basket player, and actually, Braves is also a baseball team. It's an Atlantic baseball team, if I'm right. Okay, and after that, actually, how can we just represent this kind of domain knowledge in a correct way to ensure the downstream, like clustering modeling? We actually build a document-based heterogeneous information network to do so. Why we use heterogeneous information network? Because it's a network, contains a lot of different entity types and the links between them. So, given this document, it's how we show that it's a good way to model real-world data. And specifically in our work, we use document as one entity type and word as other entity type in the network, and also other entity types specified from word knowledge to the document. We can get, them together. This is the schema of our heterogeneous information network. So after specify the document, to a structured information network. So actually, we turn unstructured data to a structured representation. And what we do is it's very natural to think about this. Okay, we can do a network partition or graph partition, just to turn a classroom problem, document classroom problem to a network partition problem, and to generate several document clusters. Okay, what we use here is actually in knowledge-based entity or concept are organized in a hierarchical way. So we use the top-level entity types as entity types in networks, and because we want to generate a more dense net graph. And actually, we use subtype, okay, and also attributes of the entity to help us to generate knowledge that could be used in the classroom model I will talk about later. So let's focus on how we do the network partition. So the model is motivated by the information theoretical clustering. What we do is actually we want to model the joint probability, along any two pairs of different entity types in the knowledge in the networks. So what we try to minimize the KR divergence between the distribution of the optimal function and also the original probability. So we do this for all the kinds of and also the edges between in the network schema. We also design two constraints, including master link and con link, using the subtype information to help us to use the word knowledge as indirect supervision. So, for example, we build a master link between Larry Page and Serbian because they are all founder, and we build a canal link between Larry Page and Facebook because Facebook is a company. And then we try to minimize such object function, to try to make the clustering distribution after our algorithm is similar to the previous one, so original one. So we design alternating optimization, try to optimize the document label and the model, and then update the entity, all the entity label, and use the cluster of the entity back to cluster, back to the document label, and to improve it more. So until it comes through a convergence, we stop it. So notice here, knowledge indirect supervision actually here is used in indirect way. So because we just know the entity type of entity, the type of the entity, but we do not know the type of the document or the label of document. So we can use actually the cluster or the label of the entity to help the cluster of document. So we can transfer this kind of knowledge from the entity using the link to the document. So let's show the let me talk about the experiments we do. We just run experiments using 4 document data sets, and we use 2 knowledge bases, which were including Freebase and Yangqiu. And also we noticed that the Freebase and Yangqiu, the anti-typing in them is organized in a hierarchical way. And I show the clustering results on continuous group here. So we actually compiled with a lot of, state-of-art, clustering algorithm with different sightings, like using the back-and-forth features and using the entities or entities from the 2 different knowledge bases as a background, as a feature. And I also use information hierarchical co-clustering and co-clustering with 215 ground truth labels, and also our method. We could notice that our method could, beat the method using the ground truth label. And there is a difference between the word knowledge. We could see here is our method with a Freebase knowledge can outperform our method with a Yangqiu knowledge. The reason is that actually we can specify more entity or more relation and more knowledge from the Freebase than from Yangqiu. So it gave us a clue that if we can get a more complete knowledge base or more like powerful knowledge base, we can improve our algorithm, the performance more. And also I show a little like parameter study. We can show that our alternating optimization algorithm can come through a convergency, and we can, if we use more like constraints, we could get better clustering results. So let's conclude this work. So we probably first study the document clustering with word knowledge as indirect supervision. We also propose a word knowledge specification framework for the general machine learning task, and using unsupervised semantic parsing and conceptualization-based semantic filter to help us to generate knowledge. And we also propose a clustering model which can make use of such representation and the knowledge we get. So thank you.
So we have time for a few questions. So go ahead.
So do you consider overlapping clusters rather than disjoint clusters?
I didn't. I just use hard clustering.
So because normally life is not hard clustering.
Yes, good advice.
Okay.
Hi.
Is there anything that turns on that final step being a k-means clustering as opposed to some other clustering algorithm?
You mean the difference between?
Yeah,
The
there's umpteen clustering algorithms of which k-means is one. Does that have an impact on the result?
Yes, sure. Actually, we use the entity labels and the entity of knowledge specified from word knowledge as the features, in the knowledge in the k-means like the other baseline methods. So what's the key difference between our method and the k-means methods is that we actually use the link information. You notice that we present knowledge in the form of networks. So actually we can transfer the knowledge, in the entity side using the link to the document label. Okay? So we can leverage such knowledge in an indirect, supervision way. So that's a key difference. Yeah.
Okay, one more question if you have. Okay. Let's thank the speaker.
Thanks.